Lesson 31, Confidence Interval Estimation for One Population Mean. Example 2. The lower leg length for a random sample of adults were measured in centimeters from the back of their bended knee to the bottom of their heel. This sample of 32 adults produced a mean lower leg length of 44.56 centimeters with a standard deviation of 2.69 centimeters. So in this example, when it states that we have a sample of 32 adults, we're given that the sample size n equals 32. And since this sample is greater than 30, we have a sufficiently large sample. And when we're told that this sample produced a mean lower leg length of 44.56 centimeters, we're given that the sample mean x bar equals 44.56. And we're told that this sample produced a standard deviation of 2.69 centimeters. We're given that the sample standard deviation, S sub x, equals 2.69. Thus, we have the given sample statistics. Based on the results of this sample, estimate the mean lower leg length of adults in the population. So in this example, we want to estimate. Statistically, we estimate using our confidence interval techniques. Since no level of confidence is specified, we will use the customary 95% confidence. Now, we want to estimate the mean lower leg length, so we're using the mean, mu, as our population parameter, of adults in the population. This involves just one population. So for this example, we'll be constructing a confidence interval estimate for just one population mean. So the following will guide us through the construction of our confidence interval estimate, starting with identifying the level of confidence, 1 minus alpha. We'll be using the customary 0.95. Next, t-interval is the command on the TI-84 calculator that will help us construct the confidence interval. But to do this, we need the sample statistics. So on the calculator, we'd press stat to do our statistics, arrow over to tests. This is where our confidence interval hypothesis test commands are found. Arrow down to the cursors next to t-interval, press enter to select. Now we have the actual sample statistics, so we arrow over to stats, and with the cursor blinking on stats, we press enter to select. Then down arrow, we input x bar equals 44.56, enter. S sub x equals 2.69, enter. N equals 32, enter. C dash level, or the confidence level, is the customary 0.95. Down arrow to calculate, press enter. And under the t-interval command, in parentheses, we have the lower limit L given first, comma, and the upper limit U given second. So we can express our confidence interval symbolically by saying 43.59 is less than mu is less than 45.53. So now that we've expressed our confidence interval symbolically, we can now express the confidence interval verbally. Based on the results of this sample, the mean lower leg length of adults in the population is estimated to be between 43.59 centimeters and 45.53 centimeters with 95% confidence. So if we work for a company that manufactures chairs, and we're going to build chairs that are one size fits all, we'd want to make sure that the chair would fit the average adult. So how high should we make the seat of the chair? Well, if the average adult is sitting in the chair, the back of their bended knee would be even with the seat, and then their bottom of their heel would lie comfortably on the floor. So we should probably make the height of that chair seat to be somewhere between 43.59 and 45.53 centimeters.